Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 10.5, Problem 8. This is Section 10.5, Problem number 8. It says, how long will it take for money to double if it is invested at 8% compounded quarterly? And then it asks, how long will it take for money to double if it is invested at 12% compounded quarterly? And then they give you a reminder, remember the compound interest formula is A equals P times, in parentheses, 1 plus R over M to the M times T power. That's from Chapter 5, it was from Section 5.1. So, what we're going to do is take that compound interest formula, A, the final amount, equals P, the initial investment, or really P for principal, times 1 plus R over M, in parentheses. R is the rate as a decimal. M is the number of times compounded per year, to the M times T power. So for 8% compounded quarterly, we want to double our money. So as long as the final amount is double what the principal is, that's fine. So I'll start with a principal of $1 and have a final amount of $2. That'll keep it simple. So if you want, you could have a principal of $73.14 and a final amount of $100 and whatever would be doubled, $146, and I forget how many cents I even had. Don't make it tough. I'm going to start with $1, and if it doubles, it goes to $2. I mean, whatever you start with, as long as you double it, it's okay. It's going to take the same amount of time. Pick something easy. And so P, the principal, is $1. A, the final amount, is $2. 1 is in the parentheses here. The rate as a decimal, so we're saying for the first part 8%. So as a decimal, 8% is 0.08 over M. M is how many times compounded per year. So for quarterly compounding, M would be 4. Close the parentheses. M times T. M is 4 for quarterly compounding. T is time in years. That's what we're trying to figure out. So the unknown is in the exponent. So to solve this, you really need a log. Again, you could guess at it with some trial and error. You come fairly close, but for an accurate answer, you really want to use a log. So let's clean up the problem a little bit. So I have 2 on the left side of the equals. 1 times the parentheses. I don't really need to write the 1. 0.08 over 4 in the parentheses reduces to 0.02. There's a 1 plus in front of that, so 0.02 plus 1. In the parentheses, I would have 1.02. And the exponent 4 times t, well, I can't simplify that too much. I'll just write it as 4t. 4 times t can be written 4t. So I have the equation 2 equals 1.02 to the 4t power. And if I can figure out what t is, that's how many years it'll take for my money to double at 8% compounded quarterly. Well, I would like to write this as a log, and usually I do that Ben-Benny trick. And when I do, the base and the exponent is on the left side of my equals, and the number is on the right side. So let me just write 2 equals 1.02 to the 4t in the other order. I'll write 1.02 to the 4t power equals 2. And now it's written in a form that I'm familiar with converting. So for exponential form, I write Ben, B-E-N, for base exponent number. The base is 1.02, the exponent is 4t, and the number is 2. So let me rearrange that into the log form, which is Benny. B-N-E for base number exponent. So I start by writing the word log, and then the base is written as a subscript. The base is 1.02, and then the number is 2, then equals, and then the exponent is 4t, 4 times t. So I can use my calculator to solve log base 1.02 of 2 equals 4t. So again, that's sort of an odd log because it's got a decimal value in the base, but that's no problem. That change of base formula for logs says I can do common log of the number, so I'll have common log of 2, over common log of the base, so I'll have common log of 1.02, which is fine. The calculator won't even mind that decimal at all. And that's equal to 4 times t on the right side of the equals. So now the numerator, common log of 2, the calculator tells me very easily. In the numerator, I have the decimal 0.3010299995. And in the denominator, I'm going to have the common log of 1.02, which the calculator also tells me is I have a decimal point, 2 zeros, then an 8, then a 6, then 0, 0, 1, 7, 1, 7, 6, 2. And that's equal to 4 times t. So now I want to divide 0.301029995 divided by 0.008600171762. So let's divide that. And when I do, the left side rather of the equal sign is 35.00278878. Now remember, that's not the answer. That's equal to 4t. I want to know what t is, not what 4t is. I want to divide out that 4. So I'm going to have to do 35.00278878 over 4 is equal to t. So the 35.00278878 is still on the screen of my calculator now. Just leave it there, go divide by 4 equals. And now what I get is 8.750697195 is equal to t. That's the number of years, t. So if you invest your money at 8% compounded quarterly in about 8 3/4 years, 8.75 something, it will double. No matter what you start with. If you start with $1, it'll go to 2. If you start with $200, it'll go to 400. Now the second part of the problem says, how long will it take to double your money if it is invested at 12% compounded quarterly? So with a higher interest rate, of course, it's got to double a little quicker, right? That makes sense. At 100%, it doubles in 1 year, so that's really quick. So if at 8% compounded quarterly, it doubles in 8 3/4 years, at 12% compounded quarterly, I'm going to guess it's got to be maybe 6, 6.5, something like that off the top of my head. Let's see how close my guess comes out to. So same process. Start with your compound interest formula, which is A equals P times, in parentheses, 1 plus R over M to the M times T power. And then put in the value. So again, if we're going to double our money, let's keep it simple. Start with a principal of $1 and let the final amount be $2, and it's doubled. In the parentheses for 1 plus R over M, I'm going to have 1 plus R, the rate as a decimal. For 12% now, it says 12% is 0.12. And the compounding for the second part of the question is still quarterly. So M, number of times compounded per year, is still going to be 4. The exponent outside the parentheses, M times T, will be 4 times T. 4 for the M, the type of compounding. And T, the year, is unknown. That's what we're trying to solve for. So now let me clean that up a little bit. So I'll still have 2 on the left side. The 1 times the parentheses, I don't really have to write the 1. I can just put the parentheses. And in the parentheses, 1 plus 0.12 divided by 4. So 0.12 divided by 4 is 0.03. And I'm going to add 1 to it. So 0.03 plus 1 is 1.03. And my exponent, 4 times t, I can write as 4t. I can't really simplify it too much. So now at this point, I need a log to solve that. I have the equation 2 equals 1.03 to the 4t power. What's t to make that true? So again, I'm going to need a log to do that. So to write it in the log form, I like that Benny trick. And to do that, typically, My base and exponent are on the left side of the equation, and the number is on the right. So I'm just going to swap this equation around. Instead of 2 equals 1.03 to the 4t power, I'm going to write 1.03 to the 4t power equals 2. And I will just remind you that that's in the Ben form, B-E-N, where B stands for base, E stands for exponent, N stands for number. The base is 1.03, the exponent is 4 times t, and the number is 2. And I'm just going to swap that around to the Benny form or log form, Benny, B-N-E for base number exponent. So I start by writing the word log. I put the base as a subscript. The base is 1.03. Then the number is 2. Then equals. Then the exponent is 4t. So now to solve this, I'm going to use that change of base formula. So the common log of the number divided by the common log of the base will give me this answer. So common log of the number is common log of 2. That's going to be in a numerator. And underneath is common log of the base. So I'll have common log of 1.03. Again, common log is log base 10, and that's something your calculator will do for you. And on the right side of the equal sign, I have 4t. So let me move up here a little bit. So in the numerator, common log of 2, the calculator will figure out very quickly. It's something we've come up with a couple of times before. It's 0.3010299995. Actually, we use it in the first part of this problem. And in the denominator, we'll have the common log of 1.03, which again, the calculator will do very easily. It is 0.012837224. And again, remember, that's equal to 4 times t. So on the left side of my equation, let me do the division. 0.3010299995 divided by 0.012837224. And what I get is 23.449772225 equals 4t. Now keep in mind, I want to know what t equals, not 4t. I've got to divide out that 4. So the final answer is going to be 23.449772225 over 4 is equal to t. And again, the 23.449772225 is on the screen of my calculator already. So I'll just press divide by 4 equals. And what I get is 5.86244363 is equal to t. So it'll take a little less than 6 years actually for your money to double if you invested at 12% compounded quarterly. I'd guessed, I think, 6.5. I was pretty close. Didn't quite hit it. A little less than 6 years if you invested 12% compounded quarterly, and about 8 3/4 years if you invest at 8% compounded quarterly.